Okay, let's dive in. You really can't miss it. Businesses, well, everywhere seem to be adopting AI agents.
Mm.
They're promising this revolution in automation, right?
Mhm.
Customer service, internal stuff.
It's a huge shift. The potential for, better experiences, more efficiency, it's massive.
Which is exactly why you're probably listening, hoping to figure out the smartest way through all this.
Exactly. The possibilities are, well, they're vast, but finding the best strategy isn't always straightforward.
Right. So today we're really digging into maybe a fresh perspective on how to actually build these agents.
Yeah, and this comes from the thinking of Rahul Singhatuvelu. He's head of applied AI at RAMP, co-founder of Cohere.io too.
We've been looking at his ideas, particularly from this piece, Rethinking AI Agent Scaffolding.md.
And what's really interesting, I think, is that his view isn't just about the shiny new tech. It's grounded in something pretty fundamental in AI history.
Yeah, that's the core mission today, right? To really get our heads around this potentially game-changing way to design AI agents. It's about building them for, like, the long-haul scalability, adaptability.
Instead of the old way, which often ended up being quite rigid.
Exactly. And to kick things off, we need to talk about something called the bitter lesson in AI research. Kind of a provocative name.
It really is. But the better lesson is, well, it's key to understanding this shift we're seeing. It tells us a lot about what really drives AI forward.
Okay, so for you listening, think of this as your shortcut. We've boiled down the key info, the aha moments, hopefully without drowning you in jargon.
The goal is for you to walk away with a clear sense of this evolution in thinking about AI agents.
Right. So let's get into it, this bitter lesson. You said it came from AI researcher Rich Sutton.
That's right. And at its core, it's a really powerful observation about, well, how AI tends to progress.
Okay, so what is it? What's the main idea?
The essence is this: systems that leverage massive amounts of computation and very general learning methods consistently win out
Win out over what?
over systems that rely heavily on humans handcrafting lots of specific knowledge and rules for a particular domain.
Huh. So it's like raw computing power and general learning beat detailed human expertise encoded into the system.
In the long run, yes. History kind of bears this out. Think about chess.
Okay.
Early chess programs had tons of human-designed evaluation functions, specific chess strategies coded in.
Right.
But then systems like Deep Blue came along, using just enormous search capabilities, brute force computation basically, and they eventually beat the world champions.
Yeah, I remember that huge deal at the time. Are there other examples?
Oh yeah, Go is maybe even more stark. People thought Go was too complex for computers for ages.
Mm-hmm.
Then AlphaGo used deep learning, trained on tons and tons of data, learned the game itself, and boom, superhuman performance without relying on pre-programmed human strategies.
Wow.
We see it in computer vision too. Deep learning models trained on huge data sets blew past older systems that used handcrafted image features.
Okay, I see the pattern. General methods plus lots of compute equals win. So how does this whole bitter lesson thing connect back to building AI agents for businesses now?
Right. This is where Singatuvelu's experience at Ramp and Cohere comes in. He saw this firsthand.
How so?
Well, early on, working with models like, say, GPT-2,
Right.
these models had limitations,
Right.
right? Smaller context windows, maybe less reasoning power back then.
Sure.
So the natural instinct for engineers was to write a lot of code around the model, what he calls scaffolding.
Like building supports around it.
Exactly. Building these detailed, specific frameworks to help the limited AI do its job. Lots of rules, lots of deterministic code.
Okay.
But here's the kicker. As the underlying AI models got way better, the jump from GPT-2 to GPT-3, GPT-4,
Massive improvements.
huge. Suddenly, all that carefully built scaffolding wasn't just unnecessary, it actually got in the way.
How? It became a constraint.
Precisely. It limited the agent's ability to actually use the new, smarter model's capabilities. The rigid structure held it back.
Wow, so the hard work kind of backfired in the long run. It didn't scale with the AI's own progress.
That's the core insight. And that's a huge deal for businesses. If you build your AI agents with too much rigid, handcrafted logic, you're building something that's going to get outdated fast.
Hmm.
The bitter lesson tells us we need architectures that actually benefit from more compute and smarter models, not ones that get hampered by them.
That makes total sense. It's like designing for the future AI, not just the AI we have today. And you mentioned this connects to lowtouch.ai's philosophy, the no-code agentic AI idea.
Yes, there's a really strong alignment there. Lowtouch.ai is all about building agents without that heavy deterministic coding.
Right.
By minimizing that rigid scaffolding, they're creating systems that are inherently more adaptable, ready to take advantage of AI improvements. It fits the bitter lesson philosophy really well.
Okay, great. So, principle established. Scalable compute and general methods trump manual engineering. Now let's make it concrete. Sengatuvelu's switching report agent at RAMP. Tell us about that.
Yeah, this is a perfect case study. The goal was to process CSV files from lots of different credit card providers
Okay, why?
to create onboarding checklists for new customers switching to Ramp, basically helping them move their transactions over.
Gotcha. And the challenge.
The CSVs were all different. Every provider had its own format, different column names, different structures.
Yeah.
A real mess.
Yeah, I can picture that. Nightmare. So, approach number one. How'd they tackle it first?
The classic way. Deterministic, handcrafted code.
Meaning?
Meaning engineers literally got sample CSVs from like the top 50 providers, looked at them, and wrote specific code to parse each one.
Code for provider A, separate code for provider B, and so on up to 50.
Exactly. Talk about time consuming.
Wow. Pros and cons. I guess the pro is it works
Yeah.
for those 50.
Right. As Sengatuvalu put it, this will just work, but it's some work. The cons, though, huge engineering effort.
Right.
Very brittle. If a provider tweaked their CSV format even slightly, the code breaks, needs manual fixing, and it just doesn't scale. What about provider number 51 or 100? More manual coding for each one.
So tons of upkeep doesn't adapt. Sounds like that rigid scaffolding we were talking about, totally failing to leverage computation. A textbook bitter lesson example.
Absolutely. Pure manual engineering doesn't get smarter with better AI or more data. So clearly they needed something better.
What was attempt number 2? You mentioned a hybrid with constrained AI.
Yeah, so here they brought in an LLM, but in a limited way.
How limited?
The idea was use the LLM just to figure out the columns in an unknown CSV. Like, okay, this column looks like the date, this one's probably the amount, this must be the merchant.
How did it do that?
Using things like semantic similarity, basically the AI understands the meaning of the column headers, even if they're worded differently, and maps them to a standard RAMP schema.
Okay, so AI does the column identification. Then what?
Then it handed off to traditional scripts to do the actual data processing based on that identified structure.
So AI for one specific messy part, but still mostly traditional code running the show. Benefits, drawbacks.
Well, the benefit was it was more general than approach 1. It could theoretically handle a new CSV format without needing totally new code,
That's better.
but it was still mostly what Sengatuvalu calls classical. The AI was just a component. You still had this complex job of making the AI part talk to the traditional code part.
Right, orchestrating it all.
Yeah, and it didn't fully embrace scaling with AI compute. A lot of the work was still deterministic, not fuzzy.
Okay, so an improvement, but still kind of tethered to the old ways.
Yeah.
Not fully embracing the AI's potential. What was the third approach, the fully AI-driven one?
Right, this was the big leap. Here, they basically just gave the raw CSV straight to a powerful LLM.
She handed it over.
Yep. But the LLM was equipped with tools, a code interpreter, like pandas and Python, or maybe Rust libraries.
So the LLM could write and run code?
Exactly.
Yeah.
The instruction was basically, here's a CSV, figure out its structure, write the code to parse it, and give me the data in our standard format.
Whoa.
And they added a verifier step to double-check the LLM's output for correctness.
That's a lot of trust in the AI, letting it analyze and write the code.
It is. And here's a fascinating detail. Running it just once per CSV often failed.
Oh. So it didn't work.
Not reliably on a single run. But, and this is key, when they ran the same process 50 times in parallel for each CSV across lots of different tricky formats, it became incredibly robust.
50 times in parallel. That sounds like a ton of computation.
It was. Sengatuvalu estimated maybe 10,000 times the compute of the first approach.
10,000.
But it generalized way better, handling diverse formats automatically. And crucially, it needed much less ongoing engineering time.
Ah, there's the trade-off. Compute versus engineers.
Precisely. He argues engineer time is the real bottleneck, the truly scarce resource, the extra compute cost.
Yeah.
Less than $1 per CSV, apparently. Peanuts compared to the value of getting a customer switched over successfully.
That completely reframes the cost equation. Compute is cheap and getting cheaper. Engineers are expensive and hard to find.
Exactly. And this third approach is the bitter lesson in action. Maximize the fuzzy compute, let the LLM do the heavy lifting, the reasoning, the code generation. The system naturally improves as the LLMs get better.
Minimal brittle code, maximum reliance on scalable AI intelligence. Yeah.
It's about trusting that computation power.
So Sengatavalu uses these three approaches to define categories, right?
Yeah, he labels them based on how much is deterministic versus LLM-driven, or fuzzy.
Okay, run through them again.
Approach 1, the all-manual code, is classical land, reliable for what it knows, but rigid.
Got it.
Approach 2, the hybrid one, is the constrained agent. AI used for specific tasks, still lots of traditional scripting, more flexible but complex to manage.
The middle ground.
At approach 3, the full AI version, is AI-driven. The LLM orchestrates everything, even writing code. Super scalable, super adaptable.
And his observation is that most companies today are stuck in that middle constrained agent category.
That seems to be the case. Lots of places are using LLM APIs, sure, but often plugged into older existing systems.
But he argues the future is firmly in that AI-driven camp.
He does, very strongly. Because of those blue arrows, the fuzzy compute parts,
What does he mean by blue arrows?
it's just his diagramming term for the parts driven by the LLM. Those parts automatically get smarter as the big AI labs release better models. You don't have to rewrite your application. It just inherits the improvements.
Ah, free upgrades, essentially.
Kind of, yeah. And he says RAMP is actively shifting more of its systems towards this AI-driven model.
Which loops back again to lowtouch.ai. Their whole platform seems built for this AI-driven world.
Absolutely. By being no code, it inherently pushes you away from writing lots of deterministic scaffolding. It's designed to let the LLM do the reasoning and decide on actions.
Using things like React and Codact.
Exactly. Those frameworks let the agent dynamically choose and use external tools or write code when needed, but the core orchestration stays with the LLM. It maximizes that fuzzy compute.
Okay, this is really starting to click. Now, Sengatavalu pushes this even further, right, with a pretty radical idea.
He does. It's quite a vision. He suggests using an LLM as the entire backend for an application.
The whole backend, not just a part of it.
The whole thing. He built a proof-of-concept email client to show it.
How on earth does that work?
Okay, so imagine you log in. The LLM gets your authentication, access to tools like a code interpreter, databases, APIs.
Right.
Then the LLM itself decides how to render the user interface, maybe just using simple Markdown. It handles your clicks, your requests. If you want to delete an email, the LLM figures out the right API call or writes the code snippet to do it and executes it.
So no traditional web server logic, no static backend code handling requests. It's all the LLM all the time.
Pretty much. It's a total flip. Usually the LLM is a tool called by the backend. Here, the LLM is the backend, calling tools when it needs them.
That sounds slow and expensive.
He acknowledges that, yeah. Right now, it probably is slower and more resource-intensive than traditional methods. But his bet is on the exponential curve of AI progress.
That bitter lesson? Again, compute scaling makes new things possible.
Exactly. He thinks eventually this kind of architecture might become totally viable, maybe even standard. As he says, things might just take off.
And you said lowtouch.ai has parallels here in a more practical, ready-now kind of way.
Yeah, think about their appliance model. They allow you to run powerful LLMs privately inside your own environment.
Okay.
That private LLM effectively becomes the back end or the brain for all the agentic workflows you build on their no-code platform.
I see.
You interact via their conversational UI or API. Their model context protocol helps the LLM pick the right tools dynamically, and the vector database gives it context. It's an LLM-centric architecture driving the workflows, making that AI-driven model practical for enterprises today.
Got it. So pulling all this theory and these examples together, what are the actionable strategies for you, the listener, wanting to build better, more scalable AI agents? Based on Sengatavalu and platforms like lowtouch.ai.
Okay, yeah, let's list some key takeaways.
Maximize fuzzy compute. Really lean on the LLM for reasoning. Minimize your own rigid code.
Let the AI think. Makes sense. Lowtouch.ai's frameworks like React Codact help here.
Exactly. They let the LLM call out to tools, but keep the core logic fuzzy.
Start with capable models. Use the best models you can access for prototyping, like OpenAI suggests. Get a baseline.
Aim high first.
Then you can see if smaller, maybe private models like the Nematron or Llama 3.1 that lowtouch.ai supports can do the job efficiently enough for your specific use case.
Good tip. Next.
3. Leverage no-code platforms. Seriously, reduce that engineering burden. Use platforms like lowtouch.ai. It gets non-technical folks involved too.
Frees up engineers for harder problems.
Precisely. 4. Embrace parallel compute. Remember the switching report. Running things in parallel made the AI-driven approach robust.
Don't just run it once if it's tricky.
Right. Scalable platforms like lowtouch.ai are built for this kind of thing. 5. Implement robust guardrails. This is crucial. Safety, compliance. You need layers.
Like what?
PII filtering, checking if the output is relevant, and definitely human-in-the-loop checks. Lowtouch.ai has a suite inspired by OpenAI's safety work.
Essential. What about when the AI gets stuck or needs approval?
That's 6. Plan for human intervention. Build in those HITL workflows for risky actions, or when the AI isn't confident.
How does lowtouch.ai handle that?
They integrate with things like OTP codes, approval links, Slack, ServiceNow, various ways to get a human involved.
Okay, 2 more.
7. Use vector databases for context. Give your agents memory and knowledge. RAG retrieval augmented generation is key.
So the AI isn't just reasoning in a vacuum.
Exactly. Lowtouch.ai's built-in VectorDB helps with knowledge bases, finding anomalies, checking compliance docs, all that.
Smart. And the last one?
8. Iterate incrementally. Don't try to build the ultimate multi-agent system on day one. Start simple. Evolve.
Crawl, walk, run.
Yeah. Lowtouch.ai lets you start with basic agents and build up complexity as you need it, avoiding that over-engineered trap.
Great list. So just to recap the lowtouch.ai connection, how are they uniquely embodying this bitter lesson approach?
Well, it's the combination. The no-code simplicity reduces the reliance on brittle, manual code. The privacy-first design lets you use powerful models securely. The architecture is built to scale with compute needs, and it allows for rapid deployment so you see the impact faster. It's really designed around leveraging AI effectively.
Can you give a couple of quick examples of where this is being used?
Sure. Think autonomous process automation agents handling multi-step business workflows.
Yeah.
Or cognitive help desks using the VectorDB for FAQs, maybe Gemini models for image-based tickets, with Slack integration for human help when needed.
Okay.
Even things like self-healing IT infrastructure agents, monitoring systems, and fixing common problems automatically.
Cool. So the big picture message is really about this fundamental shift in how we build, moving away from rigid structures towards these flexible, compute-hungry, AI-driven systems.
Exactly. We need to embrace that bitter lesson. The trend of AI getting exponentially better isn't slowing down.
And platforms like lowtouch.ai are providing the tools to actually do that today in a practical way.
That's the idea, making it accessible, secure, and scalable.
So a final thought maybe for you, the listener, to chew on. If Senghao Tuvalu is right, and LLMs could eventually become the entire backend, how does that change everything we think about software development versus AI development? Where does one end and the other begin?
It's a profound question. It suggests a future where AI isn't just part of the application. It is the application's core fabric. A very different world.
Definitely something to think about. If you want to see how lowtouch.ai's no-code platform could fit into this future for your own organization, check out their site, lowtouch.ai. That's lowtouch.ai. Or email info@lowtouch.ai.
It's an exciting time seeing how these agentic systems are evolving and what they're making possible.
It really is. Well, thanks for taking this deep dive with us today.
My pleasure.
Until next time.